Hello everyone, and thanks for watching Edupedia World Videos. In this video, we'll begin our discussion of operations on vectors, specifically the addition of two vectors, the subtraction of two vectors, and the multiplication of a vector with a scalar. So let's take a small recap of what we did in the previous video. We found out two ways to represent a vector. One was in terms of magnitude and direction, and the other was in terms of x and y components. And we saw how to go from one to the other. For example, if we have a vector with magnitude and direction a theta, then it can be represented as a cos theta I cap plus, and I'm going to often omit these caps just for the sake of convenience, but you should assume that they exist. They'll be there in all of the books which you read. A sin theta j cap. On the other hand, if I have a vector with x and y components x I cap plus y j cap, that means that the vector has a magnitude of root x squared plus y squared and an angle of tan inverse of y by x. So we can go from one form to the other. Now we'll see how to add two vectors. So what we'll do is, we'll do it in both the forms. That means, given the magnitude and direction of two vectors, we'll be able to calculate the magnitude and direction of their sum. Also, given the x and y components of two vectors, we'll calculate the x and y components of their sum. Right? And depending on the problem, we'll do whichever method is easier. The conversion from one to the other is quite simple. Then we'll do the same thing for scalar multiplication, which is the multiplication of a vector with a scalar, which is just another word for number. So in that case, given magnitude and direction of a vector and obviously a scalar, we'll tell you the magnitude and direction of the product. And given the x and y components of a vector along with a scalar, we'll tell you the x and y components of their product with the scalar. And in the next video, we'll do the multiplication of two vectors, and we'll go through the same process. Given magnitude and direction of two vectors, we'll calculate the multiplication of them. And given the x and y components of two vectors, we'll calculate the x and y components of their product. So let's start with the first one. Given the magnitude and direction of two vectors, how do you calculate the magnitude and direction of their sum? Well, first let's look at what simply the definition of addition is for vectors. If this is a vector A and this is the vector B, then what is the vector A plus B? Well, before that, a little bit of terminology. This point for a vector is called the tail of the vector, and the point towards which the arrow goes is the head of the vector. Similarly for this one. So what we do is, we join the tail of one vector with the head of the other vector. We know that there is no origin to a vector, so we can always translate them parallelly. So what we'll do with this vector B is, we'll translate it while keeping it parallel to itself, such that the tail of B coincides with the head of A. Right, this is the vector B. And now, the tail of the vector A and the head of the vector B, when they are joined, that gives me the vector A plus B, which may be written as C. This is just a more refined way of seeing what we already knew. We knew that if this is one displacement, this is the other displacement, and this is the total displacement. Right? That's what you do. You join the tail of one with the head of the other, and the tail of the first to the head of the second gives you the sum vector. So this is what the definition of a vector means. Now let's calculate the actual magnitude and direction of the sum. So the first thing we'll do is, let's say we are given the first vector with a angle A and magnitude A and angle alpha, and the other vector with a magnitude B and angle beta, and we need to add those two. So the first vector might be something like this, magnitude A and an angle of alpha with the x-axis. The second might be the vector B, which has a magnitude B and an angle beta with the x-axis. Well, what we'll do is, we'll just rotate the x-axis, just for the sake of simplicity. We've done this many times in many different things, so that A is along the x-axis. And if A is along the x-axis, then this angle would be beta minus alpha. We'll just call that theta for now. right? And that would be the angle between A and B. If A has an angle of alpha and B has an angle of beta, the angle between B and A is beta minus alpha, right? So basically, just for the sake of simplicity, and we are not losing any information when we do this, we'll assume our x-axis to be parallel to A, and then B will have an angle of beta minus alpha. Let's just call it theta. So essentially what we are doing is we are adding two vectors, one of a magnitude A and the other of the magnitude B, and the angle between them is theta, right? Now this is what I was trying to tell you. You don't need to worry about this A is horizontal. What if it's not horizontal? Well, even if it's not horizontal, you can just rotate the axis to make it parallel to the x-axis such that this is the case. And this would be the sum. Let's call this vector C. So the vector A has a magnitude of A, the vector B has a magnitude of B. It's often written as magnitude of A, which is the modulus, like the absolute value, is equal to A. Similarly, magnitude of B is equal to B. Now one more important thing, the angle between the two vectors, is it theta or is it this, which is 180 minus theta? Well, it's theta. And the reason for that is the angle between two vectors is defined as the angle between their tails or their heads. So when you extend A in this direction, you parallelly translate it like this. This is the tail of A, this is the tail of B. The angle between them is theta. What is 180 minus theta? This angle, that is the angle between the head of A and the tail of B. That does not qualify. Okay, the angle either between the two tails of two vectors or the two heads of two vectors is defined as the angle between two vectors, and in this case it's theta. So basically our question has been reduced to a geometrical problem, since we assumed in representing vectors we'll take the magnitude to be proportional to the length. So our problem basically is, given a line segment of length A, another line segment of length B with this angle theta, what is the length of this line segment C, and what is this angle? Let's just call it alpha. We need to figure out what C, which is mod C, is in terms of A, B and theta. Everything should be in terms of A, B and theta. And we also need to find out what alpha is in terms of A, B and theta. And once we find that, we'll have found the magnitude as well as direction of the sum of these two vectors, which is our goal. Well, we can make a simple construction. We can drop a perpendicular from this point, like this. Now if this is the perpendicular, then this side has a length of B sine theta and this side has a length of B cos theta, right? Now if you look at this total big triangle, the outer triangle, it's a right angle triangle where one side is B sine theta and the other side is A plus B cos theta. So we can use Pythagoras theorem to get the value of C. So what we'll get is C square is equal to A plus B cos theta whole square, which is the square of the base plus the square of the perpendicular, B sine theta whole square, which basically gives me C is equal to the root of A squared plus, now you'll have B square cos square theta and B square sine square theta, which will add up to give me B squared, and what is left is 2AB cos theta. So this is the magnitude. What is the angle alpha? We can actually calculate that easily too. In this right angle triangle, tan alpha will be perpendicular by base. Perpendicular is B sine theta. So the tan inverse of that, B sine theta by A plus B cos theta. And this is it. This is the final solution. Given a vector of magnitude A and another vector of magnitude B, with an angle of theta between them, the magnitude of the sum of the two vectors is root of A square plus B square plus 2AB cos theta, and the angle between the resultant and the x-axis, which is basically the direction of the resultant, is tan inverse B sine theta by A plus B cos theta. You should remember these two formulas, and this is often called the triangle rule of addition. Right, because we complete the triangle. Now let's just apply it in one case which we've already done to see. we have one vector of magnitude 3 and another of magnitude 4. We know that if they are together, the magnitude total is 7. If 4 is in the opposite direction, then we'll have -1, but the magnitude will still remain 1 because it's positive, the direction will be opposite. And if 4 is at this angle 90 degrees, the magnitude is 5. In the first case, the angle between the two vectors is 0 degrees. In the other case, it's 180 degrees, and the third case, it's 90 degrees between the vector 3 and the vector 4. So let's just apply this formula for alpha. Right. If we have two vectors, the first has a magnitude of 3 and the other has a magnitude of 4, and they have an angle of 0 degrees between them, the sum will be root of 3 square plus 4 square plus 2 into 3 into 4 into cos of 0, which is 1. So into 1, which gives me root of 25 plus 24, which is root 49, which is 7. What about 180 degrees? In that case, cos 180 would be -1 and you would get a minus sign here. And you'd get 25 minus 24, which is 1. So this would be 1. What if you had 90 degrees? In that case, cos theta would be 0 and c would simply be root of a squared plus b squared, which is the Pythagoras theorem. So when we started the previous video, when we started the vector algebra unit, we were able to calculate the sum of two vectors of magnitude 3 and 4 if they had either an angle of 0 degrees, 180 degrees or 90 degrees with them. But now if one is 3 and the other is 4 and they have an angle of 30 degrees between them, still we can directly find the resultant in this angle using these two formulas. Root of 3 square plus 4 square plus 2 into 3 into 4 into cos 30. That would be the answer. So given the magnitude and direction of two vectors, we are able to calculate the magnitude and direction of their sum. Now let's do the same thing with the x and y components of two vectors. So we are given the x and y components of two vectors. Let's say x1 I cap plus y1 j cap, and the other could be x2 I cap plus y2 j cap. Right. So what is the sum of these? So the first vector we can draw here, it would be a vector with some magnitude and some angle, such that this distance would be x1 and this distance would be y1. This is the first vector, right? X component has a length of x1, y component has a length of y1. Now you add the second vector to it starting here. Let's say the second vector is something like this. So this length would be the length x2, right? The component of this vector, which is x2i plus y2j, and this length would be y2. The sum of these two vectors would be this vector. But what would be the x component of this vector? This is x1, this is x2, so this total length is x1 plus x2. This is y1, this is y2, this total length is y1 plus y2. So we get a very nice result. If you have a vector x1i plus y1j and another vector x2i plus y2j and you want to add them, the x component of the resultant vector is x1 plus x2i and the y component of the resultant vector is y1 plus y2j. And this is why we spent so much time in the previous video studying a vector in terms of its components, because it's quite complicated to add two vectors in the magnitude direction form. But given the x and y components of two vectors, it's a very simple process. You just add the x components of the two vectors together and you just add the y component of the two vectors together. Right. So if there's one vector 3i plus 4j and another vector 7i plus j, the sum of the two vectors would be 10i plus 5j. Right. Now let's just look at one problem. We'll just do one problem based on addition and we'll do it on by both the formats. Say we are given two vectors a and b and we need to find their sum. A is a vector of magnitude 5 making an angle of 30 degrees with the x-axis, and b is a vector of magnitude 10 making 60 degrees with the x-axis. And let's say, to make it a little simpler, we just need to find out the magnitude of their sum. We know how to find the angle as well. I leave that to you for homework. Our goal is to find the magnitude of the sum of these two vectors. Now there are two ways we can do this. The first is using the triangle rule of addition, which is getting the answer directly in the magnitude direction form, and the other way would be to convert both of them into the x and y components and then calculate the answer from there. Right. So this is 30, this is 60, this is 5 and 10. So if the first one makes an angle of 30 degrees, the other makes an angle of 60 degrees, then the angle between them is 30 degrees. So we can directly find the magnitude of C, which is their sum, because C will be, the magnitude will be root of a squared plus b squared, that is 25 plus 100 plus 2ab cos theta, that is 2 into 5 into 10, that is 100, into cos theta, that is cos 30, which is root 3 by 2, so we get 50 root 3. Which comes out to be root of 125 plus 50 root 3. So this is the answer. You can try to simplify it a little bit if you want. Now we can do the same thing by converting them both into x and y components. So let's write both of these vectors in terms of their x and y components. The first vector A can be written as 5 cos 30 I cap or 5 root 3 by 2 I cap plus 5 sin 30 j cap, that is 5 by 2 j cap. B can be written as 10 cos 60 I cap or 5 I cap plus 10 sin 60 j cap or 5 root 3 j cap, which means C will simply be 5 plus 5 root 3 by 2 times I cap plus 5 root 3 plus 5 by 2 times j cap. And now if you wanted to find out the magnitude of C, we can just do this again. It will be root of this square plus this square, right? This side plus this side by Pythagoras theorem. So 5 plus 5 root 3 by 2 whole square will give me 25 plus 25 into 3 by 4 plus 2 into this, that is 25 root 3 plus once again this will be 75 plus 25 by 4 plus 25 root 3, which comes out to be root of, this is 50 root 3, and we are left with 75 and 25 and 25 or 125. So we see we get the same answer regardless of how we try to do it. So we finished the addition of two vectors. Now let's move on to scalar multiplication. Scalar multiplication is simply multiplication of a vector by a scalar or a number. And we've already actually seen examples of that as well when we say 3 I hat. That is basically the single unit vector I hat of magnitude 1 pointing in the x direction multiplied by 3. Right? So that's basically what it is. So if we have a scalar k multiplied by a vector a, what is that? So there are two cases for that. The first case is if k is positive, the other case is if k is negative. Right? So we'll do both of them separately. If k is positive, that means the vector ka is a vector with magnitude ka, k times the magnitude of the original vector, this is the magnitude, and the same direction. So if this is the vector I cap, this is the vector 3 I cap, which has a magnitude of 3 times the magnitude of I cap, which was 1, and the same direction. On the other hand, if k is less than 0, it's a little bit tricky. The vector has the the vector k has the magnitude mod k times a and the opposite direction. So if this is the vector I, what is the vector minus 2 times I? That will be minus 2i, which is this vector, which has a magnitude of 2. So the magnitude is mod k, mod of minus 2 times this, right? But the direction is opposite. So basically, whenever you multiply a vector by a number, if that number is positive, the magnitude becomes that amount times. If the number is negative, the magnitude still is changed by the amount of the modulus of the number, but the direction is also reversed. Right? And similarly, just multiplying a number by -1 gives me minus a, and that is the vector of the same magnitude a and the opposite direction. So if you want to multiply a vector by -5, you simply increase its magnitude by 5 and tell the direction to be opposite. Right. So let's look at scalar multiplication again from both the magnitude and direction form. If we are given a scalar and a vector, but the vector is in the magnitude direction form, we know what to do. If the scalar is positive, the magnitude is multiplied by that scalar, the direction is the same. If the scalar is negative, the magnitude is multiplied by the modulus of the scalar and the direction is reversed. What about in terms of components? So let's say you have this vector, let's take a simpler vector. Let's say you have this vector which has these two components and you multiply this vector by 3. Well, you can easily see that the x component is also multiplied by 3 and the y component is also multiplied by 3 because these are similar triangles. This angle is the same, this divided by this is equal to this divided by this. This is 90 degrees each. Right? So in terms of components, the components are simply multiplied by the scalar. And this is another example, in my opinion, where working with components is much easier. So let's say you have 2i cap plus 3j cap, which might be this vector with the component 2 and 3. If you multiply this vector by -5, what you'll get is simply minus 10i cap minus 15j cap, which might be a vector in this direction. Right? If you want to multiply 2i plus 3j by 10, you will simply get 20i cap plus 30j cap. So once again, multiplying a vector by a scalar is quite easy if you look at it in terms of components. Just multiply each component by that scalar. There is one small thing that is left, which is the subtraction of two vectors. And subtraction is basically a combination of addition and scalar multiplication. Because if you have two vectors, let's say a and b, and right now it doesn't matter whether it's in the component or the magnitude direction form, the vector a minus b can basically be simply written as the sum of the vector a and the vector b. And that, if you want to make it even more explicit, can be written as a plus minus 1 times b. So if you want to subtract two vectors, simply multiply the second vector by -1, that is scalar multiplication. And once you have the vector minus b, you add it to a, that is addition. So subtraction is not really anything new, it is just a combination of addition and scalar multiplication. Now what is left is the concept of vector multiplication, which means not multiplying of a scalar with a vector, but multiplying of two vectors together. And there are actually two ways you can multiply two vectors together. We'll do it in the next video, and we'll follow the same format we did in this video. We'll do both the vectors in the magnitude direction form as well as in the component form. Thank you.